1. That means it's actually working. Okay, so today we're going to do solving exponential functions. And I just want to work one with you to show you kind of what you're doing. This is an easy, straightforward one. So we're going to work it together so you can see the pattern. So here's the way it works. See these two? Do we agree that on number 1 that they have the same base on both sides? Yeah. Do you see that it's the same base? Here, let me. Do you see that that's the same base? We have different powers. So what does the x have to be in order to equal the other side? 5. X equals, okay, I didn't really want that. Hang on. I want this. X equals 5. That's the only way this is going to work. If I have 2 to the 5th equals 2 to the 5th, right? It was that simple. So the whole objective here is to get to the same base. Some of these are real easy, like number 2. I'll let you do number 2 on your own. Is number 2 really simple? Because it's already same base. If it's the same base, do you just set the powers equal to each other? Do y'all see that? Yes. That's all you're going to do. But what if they're not the same base? Then you got to do something, right? So when you have the same base, are you going to have to do all the rules? If you have the same base multiplied, what do you do with the powers? You add them. What if you're dividing? You subtract them. What if it's a power raised to a power? You multiply them, right? All those properties are still in play now. Do you understand what I'm saying? You're going to have to do all those properties on top of, so you're going to have to simplify each side. Each side of the equation is going to have to be simplified. The stuff you were doing on that maze, when you're going backwards and forwards, you're going to have to do that. The added twist on this is sometimes you're going to have to make the bases match. So let's go find one like that. These are all straightforward until you get down to number 4. And number 4 is a problem. There's no power of 8 that equals a power of 4. We have to go to another base. So what you have to do is look at a number and do they have a common base? What's the common base for this? What is 8? Does 8 sound familiar? Did I make you write down 8 because it was something to a power? What is it? It's 2 to the 3rd. Well, can you write 4 as base 2? Okay, so for on this one, we know that 8, and you should be really suspicious if it's ever 8 or 27. 8 is 2 cubed, 27 is 3 cubed. It's at the door. So this is 2 cubed. Well, can you look at 4 and write 4 as a base 2? So what is 4? 2 squared, and it's raised to the x power. What do I do when I have a base raised to a power raised to a power? Multiply them, right? So is it 2x? Do you see that? Does everybody see that? Yeah. So what does 2x have to equal? 3. Okay? Do you see what I'm talking about where you have to get the same base? You have to know 2's, and we'll go through the 2's, and you have to know 3's. It'd be nice if you knew 4's, and 5's are really important. 5's are obvious, right? On number 9, I'm going to back up a little bit. On 9, do you need to combine those by using... On number 5, do you have to combine those by using the log properties? I mean, not log properties, exponents properties, the laws that we wrote down the other day? Before you go and set the 2 sets of powers equal to each other, do you have to go combine them? All right, that one's easy. That one's all set up. Now let's go down to number 6, because 6 is tricky. Go down to 6. Oh my goodness. For 6, what base do we probably want? How about a 2? Do we want 2? Yes, we need base 2. So let's go through this step by step. Can I rewrite that 8 as a base 2? Yeah? Should I go ahead and distribute that x? So this is the same as saying 1 to the x power or over 2 to the 3 and all that to the x power, right? But I got an easier way to do this. Okay, that's one way we could do it. It's kind of complicated. Can we rewrite that 8? Can we rewrite that as 8 to the negative 1 to the x, and I get rid of the 1 and I don't have to worry about the 1 at all? Because it's a little trickier, right? So does that mean that's 8 to the negative x But I can rewrite 8 as a base 2, because that's what I need, right? What's 8 and base 2 again?
2.
So it's 2 cubed, and all that's to the negative x. What do I do with the powers if it's a power raised to a power? Yeah, so it's 2, and it's going to be negative 3x. That has to equal this. These powers have to equal each other, right? After that, you just go and solve it. It's a linear equation. Yeah?
So is the numerator for like fractions like that, it'll always become a negative power?
So when you have something, so if you only have 1 on top and you have a denominator, you can always move it up by raising it to the negative 1 power. Or suppose that had been, if we had written that as 2 cubed, could we write that as 2 to the negative 3? Could I have gone ahead and gone straight there? Could I have gone straight there with this? Did I mess up? That's a negative. Oh, I already did the negative. I did it backwards. Last time when I did this problem, I did it as 2 cubed and moved the 2 cubed up to make it negative, and the x stayed positive. But it doesn't matter. Either way works, right?
Yeah.
So every single time, are you going to get it base? All of these on here are base 2. I'll tell you right now, they're base 2, base 3, or base 5. Oh, wait. On the back, there's a base 4. No, it's not. It's base 2. No, it's base 4. Look at number 20. It's base 4. You can do it in base 2, but it's base 4 is easier. The rest of them are all base 2 or 3 or 5. So are you going to have to use all those laws of exponents you were supposed to learn and you were supposed to practice yesterday? Yeah, you have to use those. Got it? Okay, this is just going to take practice on your part. You're just going to have to work at it. And it's really going to take, you're going to have to really work. That means try something. If it doesn't work, go try something else. You're not going to see these on the first try every time. That doesn't mean give up. After you have figured out the pattern, they will come faster and easier, and the test will be much simpler. All right? So right now I need y'all to work. So can you turn on the lights again, Anthony, please? Thank you. Okay.